Well, hello everyone. I am here again to talk to you about your parametrics homework. So far, I have gotten some good results already, and that is very promising. So I am not going to do any of these problems from the actual homework because apparently they're pretty easy, which I was hoping that you would see that they are easy. If you need me to do one with you, please let me know. And it says sketch the curve. But if you can at least tell me, I would like to see the curve, but I also want you to identify, so I'm going to write that on here, identify the curve. Okay, and same thing for 10, 12, and 14, identify the curve. But I go to this next slide about the trig functions. So these are going to lead us into the next section called polars, and we'll talk about that soon, but see, it's all tying together, all the knowledge that you have built up so far. And so with these parametric trig functions, we are going to use the trig identity, cosine squared plus sine squared equals, what does it equal? It equals 1. So when we're going to use this, so you can see what shapes we get, and this is combining our conics and our trig, and all these things are coming together. So if you have that cosine is x over 2 and sine is x over 2, if we put these into the trig identity, so instead of writing cosine squared, I'm going to write x over 2 squared. And instead of writing sine squared, I'm going to write y over 4 squared equals 1. I'm going to distribute the squares, so that's x squared over 4 plus y squared over 16. And if you remember from conics, this is an ellipse. So that's what we have made. And you didn't have to do any transformations or anything with this for now. By the way, so our parameter with trig, let me write that at the top here, your parameter, because notice we don't have any t's in here, your parameter is going to be theta. And so we are eliminating the theta. So for the second example, same exact thing, except you have to solve for the trig first. So if I solve for sine, I'm just going to divide by 3. So sine theta equals x over 3. And here I'm going to divide by 8, so that cosine theta equals y over 8. And you're going to do the same thing. You're going to do x over 3 squared. It doesn't matter the order. Sine, cosine, they're going to come out the same anyway. Plus y over 8 squared equals 1. And again, x squared over 9 plus y squared over 64 equals 1. And you get another ellipse. One of the homework, so now you can do the rest of the homework problems in this easier manner. I did see some people already turned this in, and a few of you got it, but a couple of you tried it, but retry it now that you know how to do it. And it's just numbers 20 and 21. That's all you have to do to finish. At the end of this, I am also going to show you a Desmos demonstration of the actual parametrics in motion, and this will help you with your Desmos activity today. So thanks for watching. Okay, here it is. This is the Desmos demonstration of parametrics in motion. So you are going to be looking at one of these types of screens for one of the things you're doing in your activity tomorrow, or actually today. So I'm going to show you how this works. And what you are doing is putting the parameters of your two different functions into one function that you are going to graph, and then you are going to see like a little ball going along the path of your graph. So you're not actually going to see the graph, you're going to see the motion that's happening for two different parametrics happening at the same time, so you can see the difference of what's going on. So I'm actually using problems from your homework. I'm going to do put number 9 and number 15 on the same graph so you can see what happens and how they actually move at different times and different places. So this is how you enter it. What you're going to do is you're going to start with a parenthesis, and you're going to be putting in a big point. You're going to be putting in the x expression and the y expression as a point, xy, with a comma in between them. And you're going to use a instead of t because it's fussy about that. So this is original equation was x equals 2t minus 5. So what I'm going to do is I'm going to put the x in parentheses because it is an expression, so I have to use parentheses around that. And it'll be 2a minus 5. So that is the x expression of our first set of parametric equations. And then the y expression of this, the y equation is t squared plus 4. So I'm going to put a squared plus 4. Okay, now so you can't see anything yet, but what we're going to do is we're going to add a slider. And now you can see that little guy. And I'm going to go ahead and play and show you what happens. So, oh, it's going really fast. He's already gone. So what I'm going to do, I'm going to fix my screen a little bit. I'm going to zoom out. And I'm also going to change the distance that it goes. Instead, its default is -10 to 10. I'm going to change that -5 to 5. And now that I've changed all that, changed my screen a little bit, I'm going to play it again. And there it's slowed down a little bit because it's only going from -5 to 5. So that's a parabola, I guess. If you can see that, it's a parabola. Okay, so that's one. But I'm going to add another one, and we're going to see if they cross paths at the same time. So we're going to put in the other one. So the other equation or set of parametrics is x equals 4t squared. So I'm going to put in 4a squared and then the y part, the other parametric expression here is y equals 6t over 5 plus 9. So I'm going to put that in 6a divided by 5 plus 9. All right, now see, they have the same letter, so they're both going to share this a, and we're going to see what happens when I push play. Oh, look at that. That green one's going a lot faster than the red one, and they do cross paths. Nope, they might cross paths. It's hard to tell, but you can pause it at any time. Oh, see, he turns back, and so I don't know if they would even cross paths. So this is just to show you what's going on with these two graphs as time marches through -5 to 5. You can see what happens to these two parametric functions. And so that's something that you're going to do in your Desmos activity. And I hope this helped you out. If you have any questions about entering these in here, I've also got the instructions on the Desmos activity itself, but I hope this was helpful, and I guess we will see you soon.